Hi everyone. I'm going to do your worksheet for you, and I think you're going to think it's pretty easy. This is the 3.7 Ready, Set, Go. A lot of it's review, and compared to the notes, it was a little bit more straightforward. So first of all, it tells us to use long division. I'm not going to use long division because on all these, it looks like I can use synthetic division. When you are dividing by a linear term with leading coefficient 1, you can put the opposite of the constant in the box. And you can put the coefficients beside it. And you can synthetically divide, which means you just drop the 5 and you have your party. You multiply, you add, you multiply, you add, and you multiply. They told you there was not going to be a remainder, so that's good. Some of you did forget to finish these problems. This is the remainder, that's the number, the x, and the x squared. You have to actually write the answer. So that's 5x squared minus 13x minus 6. Okay, on this guy, if we put the 6 in the box to do the opposite of the constant and all the coefficients, you skip a line and drop a line and you party. You multiply, you add, you multiply, you add, you multiply. That was really good. I might have a new career in singing. And I might not. If you can't tell, I've been really bored. I did run this morning, which was good. But it's just not the same. It's not the same without you guys, and I miss you. And I've gained a little weight, but opposite of the constant in the box, I'm going to fix that because swimsuit season is fast approaching, guys. And I know not everyone maybe doesn't care about that, but Mrs. Bruno does. And I'm going to drop the 3 and I'm going to party. I'll multiply. Ooh, look at this little 0. What do we think about that? We multiply and we get 0 and then a 12. That's okay. See, it's okay. It all works out. So what does this mean for me? It means that's my remainder, my number. It means there's no x. That's okay. But there is an x squared. So my answer is 3x squared plus 12. Okay, if I put the -2 in the box, and I write my coefficients, 1, 6, 7, -6, -8. I skip a line, I drop a line, I party, -2 and 4, -8 and -1 and 2, -4 and 8 and 0. Ding, ding, ding. Remainder number x squared and x cubed this time, which makes sense. There was an x to the 4th here. What else can I tell you guys about my life since I'm a little bit distracted today? I finished Ozark. Been kind of trying to find a new show. I've been watching that Waco. It'd be cool if you guys could talk back to me and tell me what you were watching. If there's anything good on there. Oh, I watched that All American show. That was pretty good. Some of you guys might like that. Okay, predict the number of roots. This is easy. Fundamental theorem of algebra says whatever the degree of the polynomial is, how many roots there are. Okay, so the degree is 2. The answer is 2 roots. The degree is 3, 3 roots. Degree is 1, 1 root. Degree is 4, 4 roots. Degree is 2, so 2 roots. Degree is 6. Ooh, 6 roots. That's a lot. That's a lot. Okay, and then they're going to give us the graphs on the next page. And they're going to ask us actually to try to find the zeros. Then we can write it in factored form. So basically, if I would have told you to factor this in the past, you guys would have been like, okay, and you would have factored this one, and maybe this one. But these guys, you would have said pass, 8, 6, and 10. You'd be like, no way. But now that we have the graphs, what you can do is you can find the zeros or the roots from the graphs. So this one looks like it's at -5 and 2. Change the signs and write x minus the root, remember? So that would be x plus 5 and x minus 2. And now you just factored it. You can check it by either multiplying it out or in your technology if you want. So this guy is 3. I'm looking for 3, and I can find 3. The 3 I find are at -1, -3, and 3. So now I can write it in factored form by saying x minus the root, or just changing the signs, and that's x plus 3, x plus 1, and x minus 3. And like I said, you can check it to make sure you're doing it correctly by typing this into your y equals and this into your y equals to make sure that they are the same. Moving right along, and this is one you might miss if you write it in factored form, because you might just put x plus 2. But you guys, look, that's not what is happening here. It is not, I don't know why I put y. It is not x plus 2. So if you put x plus 2, you're going to get it wrong, because this one actually has a stretch. The stretch to it is the slope, which is a negative 2 in front, which is a negative 2x minus 4. That is why it's important to check. They're not really tricking you up much here, but anytime there's a leading coefficient on these, there's going to be some sort of stretch, so you have to be careful. This is the only one that had a leading coefficient. Okay, so I'm looking for 4 here. What I got? Negative 2, 0, 1, and 2. Okay, so just change all the signs on those factors. Now the 0, we just put the x in front. If you remember, you could put x minus 0, but that's extra. X minus 1 and x minus 2. Okay, we're doing great. Okay, 2 more. Oop, there's a little leading coefficient again. So there's a negative in front. So you will have to put the negative in front there as well. And what's happening here? It looks like there's just 1, but there's supposed to be 2. Well, that's because that's the bounce. You guys see the bounce there? Bounces indicate double roots, which means you will have to put a 2 there, showing the multiplicity of this root is double and 2. This one, we are looking for 6 roots, but all I can see is 1, 2, 3, 4, 5 unique ones. Straight pass through, straight pass through. Here's the bounce. The bounce is there, which that is the double root. So the double root would be the one that's going to get the square term to show its multiplicity. So what I have here, a negative 1, a negative 2, a 0, a 1, and a 2. Write it all out here. X plus 2. X plus 1. Now the 0 is the double root, so that will be an x squared in front, and then an x minus 1, and then the x minus 2. So it's crazy we can factor these things that we never thought we could before if you have the graph. Okay, and what's last? Oh, this is talking about the double roots. Okay, so explain that. On these, find the zeros using quadratic formula. I'm just say to use quadratic formula. I don't like always doing that. In your answers, I actually forgot to post the answers to one of them because I wrote it on the back of another sheet. 19, 20, 21, and 22. I actually forgot to copy those. But I will put that in the comments now that I remember. I'm not on this video going to do it this way. I'm going to be efficient. If I can factor, I'm going to factor. Some of them I can't. Or actually, I wouldn't do quadratic formula here at all. I would do complete the square because I prefer it when b is even. So this is an x plus 10 squared. That's what it's closest to, which would put 100 in the corner, but I don't have 100. I have 51. So to get to 51, I'd have to subtract 49. So I'm going to take that minus 49, and that will equal 0. This must factor. 51. Oh, 3 goes into it. I'm so stupid. 3 and 17. Yeah. The reason I knew it factored is because this 49 is prime. So actually, the best thing to do here would have been to factor it. So I'm going to change my mind, and I'm going to go ahead and factor it. It would be x plus 3 and x plus 17, excuse me. So what does x equal? X equals negative 3 and negative 17. If you do quadratic formula, you get there. If you complete the square, when you add 49 and square root it, you'll get 7, and you finish it out, you'll get that as well. 19 does factor for sure. That's an x plus 5, or an x plus 5 squared. So the zeros here, we are going to get a double root when you set it equal to 0. Okay, and you're going to get negative 5 as your root, but that is going to have multiplicity too. 20 also factors. There's a GCF here. They both have a 3x in common, which leaves you with an x plus 4. So if you set each factor equal to 0, you'll have an x equals 0 and x equals -4 as your zeros. Okay, this one, I could do quadratic formula, but I can just get x by itself here. If I add 11 to both sides and I square root, I will get, don't forget your plus or minus because you're looking for 2, plus or minus the square root of 11 for number 21. 22 does not factor. 22, I would not complete the square. I would actually do quadratic formula on here. X equals -b plus or minus square root b squared minus 4. A times c is -1 all over 2a, which is 2. Finish it up. -1 plus or minus the square root of 1 plus 4 is 5 over 2. Love your math. And that's -1/2 plus or minus the square root of 5 over 2. And 23. 23, I would not do complete this. I would not quadratic form. I would complete the square. The closest guy this is to is an x plus 1 squared, which would put 1 in the corner. I would have to add 2 to get to 3. This is going to give me imaginary roots. When I subtract 2 from both sides, I get x plus 1 squared equals -2. Square root both sides, and I get x plus 1 is plus or minus I square root of 2. Subtract 1, and I will get x equals -1 plus or minus I square root of 2, or square root of 2i. Okay, I'm going to post those last ones that I messed up. Sorry about that. And that's it for today.